So when we're working with exponents, there are really just probably three basic rules that we have to follow. The gist is that remember, powers increase when something gets multiplied to itself. So when we multiply, we keep adding up the powers. So here is a multiplication problem. So the coefficients multiply just like they always have. 3 times 2 is going to give us 6. So that equals 6. Now as far as the exponents go, we've got to do n to the third, which is n times n times n to the 1. So n times n times n times n. So we're increasing it by 1 power, 3 plus 1 more power. So we have n to the power of 4. So when we're multiplying, coefficients multiply like they always have, but multiplying will increase powers by however many more you're multiplying by. So 6n to the 4th is the simplified version of that one. Now when we have powers of powers, we have to make sure that the power outside the quantity, whatever the power is going to, gets distributed to each thing inside. So we have to put in invisible powers if we need to. We have 2 to the first power, y to the first power, and x to the second. So we're going to distribute this power. So 2 to the first power 4 times 2 times 2 times 2 times 2 gives us 2 to the 4th power. And then y to the first power times itself 4 times, y times y times y times y gives us y to the 4th. We just multiply the powers, 1 and 4. And then we multiply these two powers, 4 and 2. X squared times itself 4 times would be x squared times x squared times x squared times x squared. Or, here's what it would look like the long way. X times x, that's an x squared, times itself 4 times. 1, 2, 3, 4. So, of course, we have 8 x's. Or we could multiply the powers. Power of powers multiply. So, x to the 8th. Now, this will simplify because 2 to the 4th power, we can actually evaluate that. It doesn't mean 2 times 4. It means 2 times itself 4 times. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the final simplified version would be 16. We'll actually put them in alphabetical order, so we'll put the x first. So 16, x to the 8th, y to the 4th for our final simplified version. Now when we're dividing, the coefficients will divide or reduce like they always have. So 5 divided by 30. It doesn't divide, but it will reduce to 1 over 6. And then the powers, if we can picture, we have 20 a's on top, which we're not going to want to write out long-wise, and 9 a's on the bottom. 20 a's in a row over 9 a's in a row. Well, 9 of them can divide out, a over a, a over a, a over a. So we can, in essence, subtract top minus bottom. Well, 20 minus 9 will leave us with a to the 11th. So, and whatever you get when you do top minus bottom, you put it on top. And if it had come out as a negative power, we would have had to move it later. So we can leave this one invisible. If there's something else on top with it, it can be invisible. So the most simplified version would look like a to the 11th, a to the 11th power over 6. A to the 11th power over 6. Now, here we have a whole bunch of stuff going on, so we'll simplify one thing at a time. Anything to the 0 power is just 1, so this means 3 times 1, so that's just 3. Times, now this power, remember, has to get distributed, so it's getting distributed to the 1, to the 3, and to the negative 3. Powers can only multiply to other powers, so we would have 2 to the negative 1, x to the negative 3, and y to the negative 3 times negative 1 will give us positive 3. So I'm going to deal with all this in a minute. Let me do the bottom. The only thing to simplify down there is that this is a times 1. So I really just have negative 3x to the 3rd. Alright, now the next thing I'll do before I start evaluating anything is see if I have any of the same term that I could add powers, but I don't have another x up here. Don't have another y up here. I'm going to go ahead and move anything that has a negative power. So 2 to the negative 1, since it's on top, it's going to move to the bottom. And x to the negative 3, since it's on top, it's going to move to the bottom. So both of those are going to move down. Since they have negative powers, they have to move. If there was a negative power down here, we'd have to move it up. So I'm still going to have a 3 on top, and I'm still going to have a y to the third on top. On the bottom, remember this is negative 3, and I'm going to bring down a 2 to the negative 1, so that's going to go here. And now it becomes 2 to the 1, which I can leave invisible. I already had an x to the third down here, so it's going to stay here. And this x to the negative 3 is moving down, so it becomes x to the third. So I have an x to the third that was already here, and then the one I brought down. So now I can simplify this a little bit more. So I have 3y to the third on top, and negative 3 times 2 is negative 6, and x to the third times x to the third, when you're multiplying, powers get added, so I have x to the sixth. Now the last thing I'll do is reduce these numbers here. 3 can't divide by negative 6, but it can reduce, and I would get negative 1 over 2. I put the negative out front. And I would have y to the third on top and x to the sixth on the bottom. And I suppose technically we could even leave this 1 invisible, so we'd have negative y to the third over 2x to the sixth. So that's kind of a little overview of all the rules at one time.